In order for you to fully understand this topic, you must first know about discriminants. Forming quadratic equations is never an easy task, but do not fret. This video will help you break the topic down into simpler ways. Let's now go back to the topic of discriminants. We know that b squared minus 4ac is a formula used to determine the discriminant of a quadratic equation. The following tables show how the nature of the roots are identified. You must be really familiar of this table in order to fully understand this topic. Now, the whole process of finding a quadratic equation given just the nature of roots requires trial and error. There is no fixed way to find an equation given just the nature of roots. To show you, let us start with the first example. Our first example is, find an equation wherein the given roots of the equation are double roots. Going back to our previous lesson with discriminants, the discriminant of double roots must be equal to 0. Now, what values can we substitute to the variables b, a, and c so that the binomial will be equal to 0? This is where the trial and error part comes up. Since we'll have to look for the values of a, b, and c in this formula, b squared minus 4ac equals 0, we have to experiment with different numbers. Say we make 4 the value for b. What should the values of a and c be to make the binomial equal to 0? Now let's say a's value will be 1 and c will be 4. Our formula now will be 4 squared minus 4 multiplied by 1 multiplied by 4. If we try to solve that, we get 0. See? It's pretty simple. But that's not all of it. Now let's get back to the basics of quadratic equations. We know that the general form of quadratic equations is equal to ax squared plus bx plus c equals 0. Let's try to go back to the binomial we made earlier. In the binomial we came up with earlier, our value for b is 4, our value for a is 1, and our value for c is 4. Now, let's try to substitute those values to the general form of a quadratic equation. The a in the equation becomes 1, the b in the equation becomes 4, and the c becomes 4 as well. And we're done. That's about all we have to do to find our first quadratic equation. After finding our first quadratic equation, we can summarize the steps into these. Let's now go to our second quadratic equation, which is a bit harder. In this second example, we have to look for a quadratic equation with 2 distinct, real, and rational roots. If you can recall, 2 distinct, real, and rational roots have a discriminant that's over 0, and is also a perfect square. For our first step, of course, we have to find the values for b, a, and c. It's up to you what values you come up with as long as you end up with an answer that is more than 0 and perfect square. Try to pause from here and solve it on your own. By then, you probably know how to solve it already. As long as you came up with something that's more than 0 and is a perfect square, then that answer is correct. For me, I came up with 5 squared minus 4 multiplied by 1 multiplied by 3. Did you come up with the same answer, or did you come up with another answer but it's still correct? This about justifies that there are many other quadratic equations with two real, distinct, and rational roots. Well, that's all for this video, and I hope you learned a lot and were able to grasp the concept of finding quadratic equations with just the nature of roots. Thanks for watching!